In this video, I'd like to talk about velocity and speed. And so let's start with an example. We have calculated in the previous examples average velocities, but now let's calculate instantaneous velocities. All right, so here's what we do. We calculate the average velocity over an arbitrary interval and then let that interval go to 0. So let's see. So let's suppose that we're going from t, on the interval from t to t plus h. And so let's see, so we start out with t is equal to t and end with t is equal to t plus h. So the change in t, excuse me, is t plus h minus t is just h. All right, at the beginning of the interval at time t, all right, s of t is basically t squared minus 4t plus 3. At the end of the interval, we have s of t plus h, that's going to be t plus h squared, replace every instance of t with a t plus h, minus 4t plus h plus 3. Let's do the algebra on that. That's going to be t squared plus 2th plus h squared minus 4t minus 4h plus 3. And now if I subtract them to get delta s, all right, well, let's see, I'd have here all of this minus all of this, so I'll have a t squared minus t squared. That does go away. I have a 2t plus h, or I'm sorry, 2t times h, then plus an h squared. Then I have a negative 4t, and I'm subtracting a negative 4t, so those go out. I have a negative 4h. And then I have a 3 minus 3, so those go out. And we're left with this. I'm going to take out a common factor of h. So I have h times quantity 2t plus h minus 4. And then when I divide by calculate the average velocity, change in distance over change in time, change in position, I guess I should say, over change in time. All right, we'll have this is the change in position, this is the change in time, this is the displacement. Remember, change in position is displacement. This expression divided by h, which will just leave the 2t plus h minus 4. Okay, now to get the instantaneous velocity, remember I let h go to 0 so that the right end of the interval approaches the left end. The interval gets shorter and shorter. So if I do this, I'll have the instantaneous velocity will be the limit as h approaches 0 of 2t plus h minus 4, which is just 2t minus 4. Now notice what we've done here. Excuse me. And I'll write this a couple of different ways. We've taken the limit as h approaches 0 of the change in position, the displacement, divided by the change in time. And that's also equal to the limit as h approaches 0 of s of t plus h, that would be the value of s down here, minus s of t, the value at the left end of the interval, divided by the change in time h. And notice this is precisely s prime of t. We're just doing exactly what we did to take the derivative. All right, so this s prime of t we call the velocity function. And in this case, it's 2t minus 4. So that's what the velocity function is. All right, now the velocity function is just a derivative of the position function. So anything that the derivative of the function implied about a function that will work for position and velocity. Let's take a look at an example here. All right, find the velocity at time t is equal to 1. Well, if you've forgotten what the velocity function was from the previous page, that you just remember that the velocity function is the derivative of the position function, and then right away the derivative of this is 2t minus 4 plus 0. And so I just would have to evaluate this at 1. And that would be, of course, -2. So the velocity is -2. Let's take a look at this. Here's the graph of the position function. At t is equal to 1, all right, we are right here. The velocity is going to be the slope of this tangent line, which is given by the derivative, since this is the function s, by the derivative of s, that would be evaluated at 1, not t, which is the velocity at 1. Okay? All right, now, let's take a look. Find the intervals on which the object is moving to the right. Well, to the right is the positive direction. So moving to the right implies that s of t is increasing. And how do we know if s is increasing? Well, if v of t, well, I should say s prime of t, its derivative, which is the velocity, is positive. The velocity is positive. So we have that implication. All right, and similarly, moving to the left would be if and only if s of t was decreasing, and that would happen when s prime of t, which is the velocity function, is negative. So let's take a look at this. All right. Okay, we have the position function is s squared, or t squared minus 4t plus 3. The velocity function then is its derivative. Okay, that would be 2t, all right, minus 4. And if we're moving to the right, the velocity would have to be positive. So let's take this 2t minus 4 and set it greater than 0. So that's going to be 2t is greater than 4, t is greater than 2. So on the interval from 2 to infinity, the position, we're moving to the right. All right, let's take a look at that. Here's times t is equal to 2. This is the velocity function. T is equal to 2. When t is bigger than 2, all right, the velocity function is positive. It's above the t-axis. Starting at t is equal to 2 here, notice the position is getting bigger. All right, we've gone from the negative, I believe this was a -1, all right, up to 0, and then well, it looks like about 3 or something here at 4, and then I believe it was 8 at 5, and so on. So starting at 2, we can see that that's getting bigger. All right, one more idea. All right, let's find the speed at 1. Now, this, the bigger the magnitude of velocity, the faster we're going. All right, but the difference between velocity and speed is when velocity is positive, remember we were moving in the positive s direction, where s was getting bigger. When the velocity was negative, we're moving in the negative s direction. So the sign on the velocity indicates which way we're going. All right, speed doesn't matter which way we're going, just how fast we're going in that direction. So we can define the speed as the absolute value of the velocity. It doesn't matter whether velocity is positive or negative, just how big is the number on it. So at time t is equal to 1, if we recall, the velocity was 2t minus 4, and the velocity at time t is equal to 1 was 2 times 1 minus 4. That was -2. The speed is going to be the absolute value of -2, which is 2. So we're moving at time t is equal to 1, we're moving, the object was moving in the negative s direction, all right, at 1 distance unit per time unit, whatever those were, we didn't specify, all right, but the speed was positive 2, all right, in that direction. Notice, remember, if I look at this, this was our position function, and if I look at this part with the red dotted line and it extends to the solid blue line, that is our velocity function. But speed is the absolute value of velocity, so whenever the velocity is negative, speed just changes the sign, or multiplies it by -1, so that reflects it across the t-axis. So this would be our speed function, and I guess I've called this s of t. I shouldn't have really done it. I should have called this speed of t. Okay, so this would be the speed function. So we have velocity is the derivative of position, and speed is the absolute value of velocity.